There are a couple of things that you need in order to replicate the demos that I'll be showing you, other than your phone, of course, and the Adafruit BLE module. The first thing is the library. So to get the library, go to Adafruit/Adafruit_NRF 8001 on GitHub and download and install this library. It comes with a couple of examples that we'll be using to do a demo of the serial communication capabilities of the module. Later, as a second demo, we'll also be using firm ATA, which I will show you separately. And for that, with that, we'll be able to do remote control type of application, so that we'll be able to read or write to the Arduino pins via the mobile phone. So that's coming up as a second demo. Another thing that we run on your smartphone. If you go to the Nordic Semiconductor website at this URL, which is also available in the notes of the lecture, you'll be able to download the NRF UART app for iOS, and there's also a version for Android, which I haven't tested, but it should be working exactly the same way as the iOS application. It's a very simple application that allows you to receive and send text to a BLE module. You can also, and this is the location of the Nordic Semiconductors application on the App Store. You can also download the Adafruit application. So it's the Adafruit Bluefruit LE Connect, which does the same thing as the Nordic Semiconductor application, but also it allows you to use the firm ATA firmware running on the Arduino to do remote control and to read state of pins. I'm going to show you that in a few minutes. So download those two applications. Download the library, install it on your Arduino IDE, and let's go and have a look at the first demo, Callback Echo. Okay, so let's go ahead and upload the sketch for Callback Echo, and all the sketch does is to receive a message from the phone and then send it right back to the phone. So done uploading, and here's the monitor, and advertising has started. So the module is advertising itself to its environment, see if anybody wants to connect to it. So I'll start the Nordic application and connect to whatever is ready to connect. See, connection was done in a matter of milliseconds. There was no need for pins or for jumping through hoops to get this done, connected. So if I send, let's say I send a single character, Q. So there's Q. A single character was received. That's his hex version, and then it's going to send that character right back to the server, to the host, and here it is, Q. If I send a few more, let's say QWERTY, then there you go. 6 bytes was sent to the BLE. The BLE sent them back to the phone, just like that. So I can do the same thing with the Adafruit application. So I'll go for UART monitor first. So let's see, it's connected. So again, Q, and you can see that 1 byte was received, sends it right back as Q. You can also switch to hex. Oops, sorry, wrong button. I can switch to hex and have a look at the hexadecimal bytes that are coming through. So if I go, let's say for a 1, 2, 3, done, that comes over to the computer via the monitor, and there's 1, 2, 3, and there's the hexadecimals for 1, 2, and 3. Quick look at how this works in the sketch. So we import the library, we define the pins for request, ready, and reset. we create the UART object based on those pins and the constructor. Then actually skip down to the setup method. And you can see that in the setup method, we define two functions to operate as callbacks. So one is going to be for the receive callback, and the other one for ACI is called, basically the one that sets up the module when the module starts. So inside the loop, we call ACI, we call the pull ACI function, and then inside that function, the module is going to act on any pending operations that he has. For example, if it receives data from the host device, from my phone, then because we've set the Rx callback function to be Rx callback, then the Rx callback function will be called. It's going to pass a buffer of the location where the incoming data from the phone have been stored, and the length, how many bytes are stored in the buffer. And then it's going to print them out into the serial monitor. But more interesting for us right now is that it's going to just say UART.write and send the data in the buffer, depending on how many bytes they contain, back to my phone. So this is all you need to do in order to send data to a host device from your Arduino Bluetooth LE application. Let's say a single byte, then you would do it like this. You'd say UART write, and you just have your byte here. I'll just call it single byte. Right, so that's another function that you can use. If you wanted to send some text out, then you could say something like UART.print, and here just put in your text, some text to send. Out by looking at the header file of the Adafruit BLE library. So they're all down here for you to study. Now let's have a look at the second sketch. This one actually allows you to have two-directional communication. So I will upload it first. Bidirectional in the sense that you're not just echoing instructions. Okay, so let's have a look at the monitor. So advertising has started. So let's go and pick up. Okay, all right, no problem. So I'll use the Adafruit application again and go for a new connection. So now I'm going to send a message from the Arduino to my phone, and I'll just make it a single number, 1. Right, so 1 has been sent, and it appears in the window of my Adafruit application, and I'll just say 2 as a response. Let's make that a 2. Okay, 2 comes back from the phone to the Arduino, and of course the messages can be of arbitrary size. You can say hello world, right, and the whole thing will go out, and you can see the hexadecimals, 1 byte each, arriving at the other end. So the way that this sketch works, slightly different. Again, we're not using callbacks now, but again, we start by defining the pinouts and creating the object. We call it BTLE serial this time. We start the device, or we start the object. We don't set up any callbacks, and all the work is happening inside the loop. So again, we need to call the pull ACI function, and we need to call this as often as we can, so that we don't have too many operations that the Bluetooth module will have to do in one go. So we try to keep the operations queue at a minimum by calling this pull ACU function as often as we can. So to do that, we need to make sure that we are very efficient with how we use the loop. We check the statuses here, whether our advertising has started, whether the device is connected, and so on. We keep track of that status in a status variable. If we are connected, then, so if ACI and EVT connected status is true, then we do a read. We check first to see if there are available data in the buffer in the Bluetooth module. And if there is, we grab one character at a time and print it out in the serial monitor, or we can store it in a variable for later processing. Then we check to see if we have typed something in the serial monitor text box. And if we have, we'll just grab the string. And just like we did in the previous sketch, we'll use, here, we'll use the write function to send the data out to the phone. So send buffer and how big it is. So most of this, the sketch is the same as the simple callback echo, except that instead of using callbacks now, we do everything in the loop. So you can use the same techniques to create applications that make it possible to communicate between an Arduino gadget and your phone. Now, on the phone side, of course, you'll have to implement BLE functionality. And Bluetooth makes available an open source application. The BLE Connect application is completely open source. So in order for you to learn how to include this kind of functionality in your own iOS applications, you will have to study this code. As far as I know right now, there's no easy to use step-by-step guide to do that. So you'll have to do a bit of reverse engineering and learn how to do this by looking at the Adafruit BLE iOS app. Again, one of those is coming up. All right, the last thing I want to show you is FirmAta, which is a way to remotely control an Arduino